So this module is really very simple equations. There's basically 2 or 3 equations that we have for the whole chapter. Plus we have to use the right-hand rule to figure out directions. So let's start off with the right-hand rule. So we've got a table here where we've got the direction of propagation of the wave, the electric field direction, the magnetic field direction. And we're given 2 of the 3, and we're asked to fill in the remaining one for a given wave. So remember, in an electromagnetic field, the electric field and the magnetic field are perpendicular to each other, and that's also perpendicular to the direction that the wave is traveling. And since they're all perpendicular, we can use the flat hand rule. So with the flat hand rule, take your right hand, you put it flat, the fingers point along the electric field, the palm points in the direction of B, and then your thumb will give the direction of V, the direction that the wave moves. So let's draw on here a coordinate system, so north, south, east, and west. And up will be out of the page, and down will be into the page. Okay, so we've got the wave moving north, and we're told the electric field is west. So the direction of propagation, take your right hand flat. Direction of propagation, that's your thumb. So you need to lay your hand so that your thumb is going towards the top of the page, or your top of your screen right now, and your fingers are pointing west. So if you do that, you're going to find the only way you can do that is that to have your palm facing out. So the palm is the direction of the magnetic field. So that's out of the page, or we might call that up towards the ceiling if you're doing it on a flat sheet of paper. Okay, so that's the first one. Let's do the second one. So second one, we're given direction of propagation still north. So our thumb is going to be pointing up towards the top of the screen or the top of your sheet of paper. And the magnetic field is to the west. So I need to have my thumb pointing to the top of the screen and my palm pointing over towards the left side, towards the west. And so the only way I can do that is if my fingers are pointing into the screen. So the electric field is in to the screen, or if you have your sheet lying flat on the page, that would be down towards the floor. All right, next one, I've got direction of propagation is up. So this is out of the screen. So I'm going to put my thumb out of the screen and my fingers pointing south. So that's the electric field towards the bottom of the screen. So if I do that, I find that my palm is pointing towards the east. So my magnetic field is towards the east. All right, so we're always given 2 of the 3. Align your hand so that the 2 of the 3 are correct, and then the other direction will be given by your hand. All right, so electric field, that's the way my fingers are pointing, is down. So that means in to the screen. So take your right hand, point it so that your fingers are into the screen. And then the magnetic field is south. Magnetic field is the palm of your hand. So you need to have your fingers pointing into the screen or into the paper. If we go flat on the desk, I guess. Now rotate your hand so that your palm is facing towards the bottom of the screen, towards the south direction. And you'll find that makes your thumb point over towards the left of the screen, or west. So the direction of propagation for that wave will be to the west. So make sure you practice this. There will be a concept question on the test, either the midterm or the final, where you have to do this. So make sure you know how to do it. All right, next question. We have the Mars rover, which was on Mars and from July of 1997. The radio signals took about 6 minutes to travel. Sorry, I was interpreting that incorrectly. All right, so it took 12 minutes to go from Earth to the rover. So I want to know how far apart were the Earth and Mars at that time. Sorry, I'm a little bit tongue-tied here. All right, so here I've got my 2 planets, Earth and Mars, and I've got my radio signal The radio signal we know travels at a speed of c, 3 times 10 to the 8 meters per second, as it goes between them, and it takes a time of 12 minutes. All right, so I want to know how far is the distance between them. Well, remember, distance is equal to speed times the time. All right, so the speed we know is 3 times 10 to the 8 meters per second. What's the time? Well, the time is 12 minutes, but remember, I got to put that time into seconds. So 12 minutes times 60 seconds in 1 minute. So the units of minutes cancel out. So 12 times 60 is 720 seconds. So I'm going to put that in there. And I get that my distance is 2.16 times 10 to the 11 meters. So that's pretty straightforward.